Good afternoon, everyone. My name is Muhammad Kawanabi bin Sabri. Today, I will be presenting my analysis on predicting student grow up. I utilize logistic regression within Sasvaya to determine if specific factors, particularly financial issue, could reliably predict whether a student will leave their studies. To build this model, I use stepwise selection method. This is an automated process that adds variables to the model and tests if they are statistically significant. If they are statistically significant, as you can see in this table, the algorithm essentially tries to include the variable financial issue in step 1. However, in step 2, it removes the variable. Why? Because the model efficiency score, the SBC, actually improved when we took that variable out. This was the first indicator that financial issue might not be a strong predictor for this specific dataset. I further investigate the statistical metrics to understand why the variable was rejected. In statistics, we generally look for a p-value less than 0.05 to consider a result significant. However, looking at the parameter, estimate the p-value for our intercept is approximately 0.95. This is extremely high. It tells us that this specific parameter is statistically indistinguishable from zero. Essentially, the relationship we are looking is likely just a random noise rather than a meaningful pattern. So, how accurate is the model overall? The most critical number here is the average square error, or we call it ASE. You will notice the ASE is exactly 0.2500 for the training, validation, and testing data. In a binary prediction, yes or no, a persistent error of 0.25 typically means the model is just guessing the average for everyone. It is not successfully distinguishing between students who drop out and those who stay. We can confirm this random guessing behavior visually by looking at the ROC curve. In a successful model, we would expect this curve to edge up towards the top left corner. However, here we see a perfectly straight diagonal line. In data science, this represents a random model. It means our predictive power is effectively the same as flipping a coin. This confirms that the current data inputs are not sufficient to identify at-risk students.